right, this is Honors Algebra 2 Pre-Calc. We're doing homework review for 2.7 in Pre-Calc. We're doing number 33 on page 184. So this is a partial fractions decomposition problem. So as you may recall, the first thing we have to do is fully factor a denominator. So this is one of those secret quadratic trinomials, right? So it's not quadratic, it's next to the fourth, but if you were to call x squared u, then x to the fourth would be u squared. So if you look at it this way, this is u squared minus 2u minus 8, which would factor as a quadratic trinomial, into u minus 4 times u plus 2, but that u is actually an x squared, so I have an x squared minus 4 times an x squared plus 2, but this guy, this x squared minus 4, is actually a difference of squares, so it ends up factoring into an x plus 2, x minus 2, and then the quadratic factor x squared plus 2, right? So I have linear factor, and quadratic factor, right? So what that means is that my setup for my partial fraction decomposition is going to be an a over an x plus 2, plus a b over an x minus 2, plus a cx plus d, which would be linear, over this x squared plus 2. Okay, so that's my setup. And again, my common denominator is this crazy mess over here, right? So once I get past the setup, I now need to make sure that all of these fractions have the same common denominator, meaning I'm going to multiply them by whatever they are missing, right? So that means that this a fraction is missing the x minus 2 and the quadratic term, the x squared plus 2, right? So an x minus 2 and an x squared plus 2, right? The b term is missing the x plus 2 and the x squared plus 2, and also up here the x plus 2 and the x squared plus 2, which I'll deal with in a second, make this a lot nicer. And the cx plus d term is missing both the x plus 2 and the x minus 2, or if you wanted, you could write that as an x squared minus 4, right? Because it was a difference of squares. Okay, so that's what these guys are all missing, right? So if I now have the same common denominator across the board, what I can do, I'm going to give myself a little bit of room here. What I can do is I can look at the numerators only, right? Because they all have the same denominator, so if you want to think about it this way, it's like you're multiplying the entire equation by that denominator of the x plus 2, x minus 2, and the x squared plus 2. So that means that this side is going to be an x squared, and on the other side I have an a times an x minus 2 times this x squared plus 2, plus a b times the x plus 2 times the x squared plus 2, plus this quantity cx plus d times the x plus 2, x minus 2. Okay, so here's the thing to notice. This looks kind of crazy, right? But I can use clever substitution to find most, if not all, of these values, right? So I can knock out any of the x minus 2's, right, which is the a and also the c and d. I can knock them out by picking x equals 2. So if I plug in x equals 2, that's going to knock out anybody that had an x minus 2. So I'm going to get 4 on this side. I'm going to get 0 because this whole term will be knocked out by that 2 minus 2, right? Plus b times a 4 times a 6, right? Plus this whole thing's going to get knocked out because it doesn't really matter what these values are. This is going to be a 0. So I end up getting that b is a 4 over 24 or a 1/6, right? So that's my b. Now I can do the same trick to find a, because if I plug in x equals negative 2 to all the x plus 2's, they're going to go away. So if I plug in x equals negative 2, I'm going to get the same positive 4 on this side, right? And then what's going to happen is I'm going to have an a times a negative 4 times a 6, plus, and both of these guys are going to get knocked out because they both have that negative 2 plus 2, which will be 0. So I end up getting that my a seems to be a negative 1/6. Cool. Now, I can actually knock out c pretty easily by itself because c alone is sitting right next to an x. So if I plugged in x equals 0, I will knock out literally only c, but using my knowledge of the rest of the stuff, I should be able to find d. So I'm going to go ahead and plug in x is 0, right? And if I plug in x is 0, I'm going to get a 0 on this side equals. Now, I already know that a is a negative 1/6, right? I know that when I plug in 0, I'm going to get a negative 2 times a 2, plus my b was a positive 1/6, and this will be a 2 times a 2, right? And then since c is 0, or since cx is 0, right, x is 0, so cx is gone, I'm just going to get a d times what seems to be a 2 times a negative 2, right? So when I clean all this up, I end up getting 0 equals, well, this would end up being a 4/6 that's positive, and this is also a 4/6 that's positive, right? So essentially I'm going to end up getting 8/6, or 4/3, right, minus 4d, right? And so it seems to me that when I move the negative 4/3 over, right, I get negative 4d, and when I divide by negative 4, I seem to get that d is 1/3. Okay, so now this is a lot of space, and it's great, but I'm going to have to erase this so I have some time to find c, which is the one that I'm missing. So I'm going to write down what I know. I now know that a is a negative 1/6. I know that b is a positive 1/6. I know that d is a 1/3, right? That's what I've got. Now, the last thing I need to do is figure out what c is, and honestly, I could pick any x in the whole world if I want and plug in, because now that I know a, b, and c, what I could do is just pick any x in the whole world that's easy. Now, since I already used 0, the only other easy x I can think of is 1, so I could pick x as 1, and I know every other quantity, and that'll let me find the value of c. So 1 squared equals, well, that's a negative 1/6. 1 minus 2 is a negative 1. This would be a 3, right? Plus b was a 1/6. 1 plus 2 will be a 3 times a 3, plus c was the thing I don't know, so c times 1 plus 1/3 times a 3 times a negative 1, right? And I get that this is no fun. It's a really hard problem, but you'll survive. Now remember, the other option is that you could have actually FOILed everything out and then done the left side equals right side, and that might be easier here, but I didn't pick that. I picked clever substitution. So I get 1 equals, this is going to end up being a positive half, right? This is going to end up being 9/6, which is the same as 3/2, so plus 3/2. Well, that's nice because that'll be a 4, right? Plus, this whole thing is a c plus 1/3 times a negative 3. So I seem to get 1 equals, well, this is 4/2, so that's 2. Plus, when I distribute this, I get a negative 3c minus 1, right? And when I put my like terms together, I get 1 equals 1 minus 3c on this side, right? So 0 is negative 3c, and it turns out after all that work that my c is 0. So now I know up here that c is 0, right? So my very last job is going to be to write my expression, this setup I have in blue up here, with the numbers instead of these letters, right? So it seems to me that my answer, and I'm going to show you why our answer might look a little different than the one in the book, is going to be a, which is the negative 1/6 on top of the x plus 2, and we'll talk about what to do with that 6 in a second, plus the b, which is a 1/6 over this x minus 2, plus the c, which is a 0x, so 0x plus 1/3, all over this x squared plus 2. Now, so here's the deal. You shouldn't leave a fraction in your fraction, so what you should do here is put these 6's on the bottom. So you should make this a negative 1 over a 6 times the quantity x plus 2, right? Plus a 1 over the 6 times the quantity x minus 2, my bad. Sorry, minus 2, right? Plus a 1 over a 3 times this x squared plus 2. Now, that answer is totally fine. It's not the answer that the book has. What the book does is instead of writing this as a 1/3, they make this a 2/6, and then they factor out the 1/6. So what the book does is takes this 1/3 and makes this a 2 over 6 instead, and factors a 1/6 out in front. What that leaves you with is a negative 1 over this x plus 2, plus a 1 over the x minus 2, plus a 2 over the x squared plus 2. And that's also a totally acceptable, completely okay answer, right? So I would have probably stopped here. You also could have distributed this and made it a 6x plus 12, and made this a 6x minus 12, and made this a 3x squared plus 6. Any of those options are fine, but again, this is just the one that the textbook picks, and that's totally okay.